Hi, I'm Ahana. I was the project manager.
Hi, I'm Sumedha. I'm the data engineer.
Hi, I'm Aastha. I'm the machine learning engineer.
Hi, I'm Christian. I'm the backend developer.
Hi, I'm Karun. I'm the front-end developer.
Hi, I'm Kathy. I'm the feature engineer.
About our project. Our computer vision project detects signs on the road and voices out this information out loud. The model is meant to support blind pedestrians who wouldn't be able to use their canes to understand these aspects of the surroundings so that they can more safely navigate around. Why did we choose a project? When we began to brainstorm for projects that we could do, we decided that we would like to create something that would help people with disabilities or just anyone who needed the help. Because sight is one of our senses that shape society more than others, because of signs and visuals that are used for several different purposes, we chose to help those who are visually impaired. Out of the many signs in the world, we decided as a team to focus on signs displayed on sidewalks and roads where blind pedestrians may be unsafe due to cars and other hazards.
So this is our tech stack. It's basically a stack of all the technology that we use to create AI detects pedestrian signs. So going chronologically, the first thing we used was RoboFlow to label our data and separate it into classes. And then the second thing we used, which is the most important one, is YOLO version 5, which we used to train our model. And then we actually had added an additional feature to make our project more like applicable to the cause that we're supporting, which is text to speech. And then for our website backend, we used Flask. So I'm going to talk about the two ways that we got our images. The first of these is web scraping. And to do this, we had to run a piece of code in Google Colab, which basically searched in Google Images and then downloaded like the first however many images you wanted, renamed them, and then put them into a folder in Google Drive. This saved us a lot of time because it's a lot easier to just run one piece of code than to manually download images. And this was our first option, but move to the next slide. If that didn't work out, which sometimes it didn't, we would have to do manually searching. And instances of where web scraping wasn't the best option was when we were working on caution signs, because if you search online for caution signs, the results are so varied that it's not really useful to us. And if we did try web scraping, we ended up deleting like 90% of the images we got, which made manually downloading them a better option. So moving on to our classes, we had 8 in total. The first 4 are this Go Cross, electronic crossing sign, no pedestrians, pedestrian restricted, pedestrian stop signal, it's the opposite of Go Cross, and then school zone crossing indicates a school zone.
These are our other 4 classes, which are stop sign, which is a standard red stop sign you see on roads, the stop do not proceed, which is the do not enter sign, which is red with a white bar in the middle, and then the crossing sign, which is basically a pedestrian on a sign that indicates where one can cross the road, and the caution sign is a yellow sign with an exclamation mark, and it's either a triangle or rhombus, and it does not refer to the indoor caution wet floor signs or like other indoor signs.
So when we began training, we were somewhat successful. Had a few, most of our classes were technically successfully, but there were definitely some that needed improvement. And our major takeaways from our first training were that our caution labels were the least often detected, but the go cross predictions were most likely to be false positives. So in our second training, we definitely improved on some of the classes that we needed to improve our detection. But we still need to improve the caution and stop do not proceed classes. And the main issue with those was that our labels hadn't been cropped down as well as we needed them to be. So that's an improvement that we made into training as we went into training number 3. But the biggest takeaway from this one was that caution did improve significantly, although the precision was still very low for that class. So in our third training, most classes were detected 100% of the time. Caution was the only class that had decline in recall, but only slightly. And this compelled us to train 2 more times, but we still ended up selecting this model even after training the other ones because it still had the most classes with 100% recall. It had the highest average recall, and our improvement in precision was only slight compared to the effectiveness in detecting all of our classes.
Throughout the process, we faced several roadblocks. One of the roadblocks we faced was that the more we trained, the lower the precision became. The caution sign had an abnormally low precision and recall compared to other classes. There were many different versions of the same sign, so we had to figure out which version of each sign we should use. And the text-to-speech feature was hard to incorporate.
So for the text-to-speech, we used Google text-to-speech. There is like an example of some of our code. Adding on to some of our challenges, our main one was putting the audio on the website. So some of the things we did to like solve this issue was we added code to the results.html page. In addition, we also created MP3 files for each label. And then we used the URL function to be able to access these files on the actual page.
Now moving on to the website. So our developing process started off with choosing a template to work on to fit our model. And we chose an AI camp website template related to the emotion detector. The website template had to be changed in several ways, such as the number of sections, what section we planned to include the images, about our project, the links, and much more to better suit our project. Some of the problems including fixing the links at the top and for the next photo button and incorporating the text-to-speech function of our model. Thank you. So now I will be showing you guys the website itself. Okay, here is our website and share computer sound. Oh. Here's the team, our work, and then yeah, that's pretty much it. So let's try out this. All right, so in downloads, and then let's try this image first. It's a little slow right now. There we go. With 93% confidence, we got this door. Now let's try a picture that has no signs on it. It's loading. See, no signs, but it came out as go cross because color similarity, right? Another picture, this image with a lot of signs on it. Let's try this one. All right, detected 2 signs, stop sign and the do not proceed. Another one, let's try this one. School zone crossing with 92% confidence, really good. And last but not least, this one. 92% confidence, go across. Let's see if there are any more. Let's try this one. Let's see if anything will happen. It detected the stop sign.